Sorry. There's a, yeah.
Oh, yeah.
So I thought that it's, and we're hearing about potential I got distracted. All right. So now we are on this little problem. We have to question. If I have a place weight like that, let's say the that lines, it's a perfectly white ball. Perfect. Okay. Now, what can you see? You see something, it has to have a border, has to have some. How can I identify border? I think she would follow that's complicated. Something simple. It's something different. Some shade has to happen. If I'm wearing a white shirt, pure white shirt, and I'm standing in front of a pure white board, and you can't, my face is not there, you cannot see the two difference, right? Yeah, I mean, theoretical, of course. In order to identify anything, you need to have a shade. We will call this as an event. And event means, even if this is also an event, because it happens in time, it's an event, then it's typically in space, we call it an object. Right? But if there is no change, there is no event, no object. In fact, I will challenge you. Can you ever think of anything which is without time and space? Like the warehouse. But when we went into the joke of time and space, the last years of time and space, I will be this. Then you don't take anything which is about no time and space. Black hole. If it's a black hole, it has to be in something else. Well, isn't something right? I mean, there's something else. The time as we know it doesn't work. What is that? Time is simply a measure of change. It's dimensional change. Something has to change. And that change has to be in space without the two opposing things. And opposing automatically time and space. So if there is anything which is going to be without time, the word without time means impossibility. Obviously, it's always there. It's never dies. Touch the day because of the paper. Put anything to it. Because anything that you can think about has to have meaning and meaning. Anything that you can visualize has to have a change. They're talking about right now, I don't think, if any of you guys doesn't possibly think about this in one time way. Right? We are not discussing the gravity. Whereas I would be on this. Then we're going to be talking about it on the other side. Okay. What does this mean in this context? Sometimes we talk about EMG. And we are not going to time and space. If the signal is remaining like this continuously, there is no change. So what I've done is, there was a changing signal. From that changing signal, if I pull out something which is not changing, I will take a steady number. Now I have to learn to see that there is a limit over which there is going to be a change. Only they can determine if there was a change. Or replacement. So if I'm doing spectral analysis or RMS analysis or any other analysis, what am I going to be getting? So if you come across the term time frequency analysis, how many four, six, eight, how many of you come across the word wavelength analysis? Why do we do wavelength analysis? For what reason? Or I'm using the word time frequency analysis in more generic sense. Wavelength is a specific. And what does that mean? Time frequency analysis. What is time frequency analysis? We call it tier analysis, right? So now people who do not know what is tier or time frequency. We don't want to know what is frequency analysis. We done FFT or something like that, spectral analysis. Is there anyone who's not familiar with it? Everyone, absolutely. Can you do an FFT analysis of a signal? Do you not know? Do you know what is frequency? Frequency analysis. No. If you're only one person, I'm sorry, I cannot have a comment now. So, frequency analysis typically is largely based on the work that was done released by Fourier, or popularly as a person Fourier transform. Okay. And from the Fourier transform, what do you get? You look at any signal, and now you're getting a trend of the signal in terms of the frequency. And you say, like, if this is a pure sine wave, what do you get here? Go on. The big. Spike. Okay. And if you have got something, six of them, okay, as I do remember when you get to have a square. I'll give you a hint. He's already given a hint. The word starts with S. Same function. So you get a spectrum which looks like this. Right? Remember this? Now, long time ago, what about it? You're studying, right? Now, what are these things telling? By the way, I did this as a 1-minute course for you. So, when you're doing this, it's telling you a trend of the signal. the regularity of the signal, the movement, the change of the signal happening. Right? Now, when you are doing this, it takes the signal. What is one thing that the signal this assumes? Does anyone remember the formula for Fourier transform? Someone help me. E to the power minus j omega t dt from plus it. Is this ever possible? Can this be ever feasible? Can we ever have a minus infinity? Can we ever have nothing? We are assuming that the signal is stationary forever and ever. Right? And just before this, we were talking about time. Okay? So if I maybe that means timeless. But it's timeless. It cannot be because by definition we talk about. But we're not talking about that. What we're talking about is that there is a problem. So we have to assume that this keeps going forever. And from here forever. Obviously there was something and this means that this is while a very nice concept, it is not practical. Then what do? You mentioned something. So we put a minus t to plus t function. So we are now approximating. But when we approximate, we are going to get equilibrium. Okay. So we have to understand how do we manage this approximation for our application. And from this is where the term wavelength goes. But we will not go down that path. Okay. So once I got this done, now the spectrum is not looking like this. How will it look like? Now I've got this big frequency x of f. But now there is also that this is valid only from minus t to plus t. That means if I take this of this for the next one for plus t to plus 2t, I need another one. Understand what I'm doing? This is valid. Let me give another. Just make life a bit easier for understanding purposes. I make this from 0 second to 5 seconds. Okay. This random number I put out. Don't take this number zero. And then I go, this one becomes 5 seconds to 10 seconds. And then there will be another one which will go 10 seconds to 15 seconds. That means I keep getting a spectrum at different windows. Now, of course, depending upon the application, this 5 or t or whatever we use, I'm really suspecting. So maybe this is the way it makes sense. If I'm doing something else, like maybe even an hours, depends on the application. Typically, what would you expect? you are doing PhD. Typically, most of our people consume the 3 hours in a matter of minutes. But we apply the people of the world. So if that is the case, we can then have a guesstimate of what is the time should be on. So, one contention is this. If you want to do spectral analysis, what you need is not just take the whole signal and say, hey, I don't say. What we need is and that is done, of course, when you're doing this. First thing is, when I'm with the signal, I don't want to speak. Then on top of that translation, I am now coming up with a magic number. Based upon some experience I have all of my friends. Again, so where you show is, we are going to be saying this is exactly what it is. So this lady decided to try out this and the signal analysis and get some result. With the same thing, might get something. Based upon what kind of number to be chosen. These are all the parameters. So one of the parameters I've chosen is time. What other time? And many who've done it will see that. What other parameters I know? What other parameters we can choose? And resolution. So how much of the resolution do I have? Remote frequency and time. Why is that important? If I have very high, I then need a very complex system. I want to have a very nice system. Virtually, honestly, it's something to say. Okay? Okay. Is this making sense? What we're going to do is count. We'll work within groups. I want you to do one thing. I want you to try out. Single analysis. First one, I want to list pilots. Why is it? Second, I want you to do this. I want you to try out FFTs and time frequency analysis. Did you do this activity? Did you record it? But for that activity, based upon the speed at which you did, not speaking, 1 second. I want you to have a look whether you can estimate gravitational cycle. Okay? Like that? Can you do that? We have enough knowledge, skills, sources, sample, it's one.
So here it comes here. Then go down.
Yes, you have to, yeah, nice. So I want you to be able to see the EMG going up and down. Okay? Yeah. Did you do this with load and ground group? I'm already giving you the secret. What I want you to see. I want to be given to you as a supply plan, which you will. But you have not ignored the actual place. And I showed you yesterday that what my skin was a muscle. So, I think that point should be happening. If I am moving, it is like as if I'm moving the actual numbers. What is the word for that? Artifacts. Well, anyone who knows the motion artifact levels? Has anyone done something? No? Okay. Yes. How many of you want me to go? Okay. 1 minute on this. 5 0. Okay. This is the state of a person. These are the electrodes, and there is a differential. Now, what happens? In order for this connection to happen, there is some charge coming. If this is coming, then this has to get charged. For that to take place, I put in something called the chair, which is built into all of these electrodes. Here is nothing but soil water. Soil water is typically with some cream, it doesn't flow. Okay? There's nothing else to it. In fact, you want salt to protect, you want some ions. So when I have these ions coming here, there's a flow of current. Now, if you have any nervousness, not the energy which I can get out. You know what happens? It's a C value and L value and R value, right? When you have all of these, you have a decay value. Okay. Also referred to as settling value. When you have these 6 values, that means it takes small amount of time for the system to stabilize. Okay? So when I put this on, I will get some activity and it will come down to 0 at this point. Yeah. Okay. Now, if this guy gets moved, okay, if this moves from here to here, what's going to happen? The position has changed, so that means this guy has to start again. It has stabilized, it is down to 0. Now you suddenly get it again. That means that if you were recording the signal has got interrupted with this noise. And many times, most times, this will be much more than the signal in itself. This is called motion artifact. Right? And obviously, this is typically low frequency. can see it, ECG, you can see all of the person, you will see the signs. Okay. Now, why do you want to know about functionality? They will shift the baseline on the frequency or on the signals. They will then obviously change the magnitude of the signal. But for now, in this number context, what is happening? Assume this here. Now let's break it down further. I've got this is my scale, and there's a muscle. And this entire thing is moving with respect to okay. Okay. It's there. So there's a relative movement between these two. So now what is happening is that this guy, when it was capturing an action potential going here, it is moved away. You are now getting another kind of a movement out back there. You're getting a signal. One is, it may not be corresponding to actually the key. It's corresponding to a movement that is happening. Okay? Which means that I want you to be able to see that even when it is no load, and you move, you suddenly get a big signal. And you might think that as EMG, but it is not EMG. And for that purpose, import AUR with some experimental logic, which they import. But be extremely careful, because the chances are that you're picking up some help. So, as much as possible, if you are going to be doing EMG in the world, I don't know what to do myself. What do you EMG? Make sure that you're only doing asymmetric. Not doing asymmetric. You have to think about the information. How are you overcoming problems? B is not the simple solution. But isometric, you can from outside at least. You can come up if you use very quick form and show the other things. You have got potential of solving. I think we're looking at. Here, you don't have. Okay. So, I would recommend this. There are a few papers on this topic. There's a couple of Robert or Maleki. I think in the EMG world, perhaps one person whom I would trust would be this guy. Either the lab or person from the university or and to the best of my, he's taught me a lot. And he's one of the few guys in the EMG I would trust. So I have to look at it for it. Based on this, he developed a new method, which again he accepted. But that is one thing which. If you look at a journal like Journal of Electrophysiology, electromagnetic, those are the kind of journal which basically talk about that as if EMG was magic, which we know it is not. So be careful about these things. Okay. Any questions? Okay. So now, what I want you to do is, in the afternoon, and if you have time, try out. When you have done that, but what I'm doing now is that how beautifully please. That's the way to do it. See what it is. So now we have to do that. Alright. RNS for FFP, time frequency analysis. So these are all the features to be done. Yes, I heard something. Someone said something. You said, okay. Pre-processing. Anyone know what he's talking about? Signal acquisition. Signal acquisition. What have we done the signal acquisition? Noise. So before you do any of these analysis, you will have to make sure that the signal quality is good. And as we yesterday saw, you can be picking up fields, can be picking up motion artifacts, you can be picking up other ones. Okay. If you're doing that, you got to do some kind of a pre-processing. And there are many ways of doing it. So one of the ways is, and you want to remove 50 hertz. How do you remove 50 hertz? Notch. Then, motion artifact, you want to remove baseline. What do you do? You put a high pass filter. So you remove the very low frequency. Get rid of the high frequency noise, you'll put a low pass filter. So typically you put all of them together. So now, okay, what else? So after we've done all of the pre-processing, we're going to have a look at some of these factors, RMS, FFT, and time frequency analysis. And if the helper teacher wants to do entropy analysis, great. So you got this entropy you wish to. Okay. And now you want what it means. What I want you to do is, okay. Of whatever you can recall these signatures from the discussion that we have had and from the signal that you have recorded. Whatever you can make it stay. Your observation. And lots of questions. Yes, get the same thought as well. Your girls and boys complete the experiment. Was there any difference? You know, something that says, I want you to put that in that, I want you to do what you want. So, when you have that, then when you did low load and high load, what happened? I said that they made me a movement between the skin and the muscle. Is it true? Then, how come the big thing I was muscle fatigue, medicine, and you actually see something? Or is it just some story with about how muscle force? Was it a really sleep about it? How I really came to what was I want to take your considerations. As a so that based on that, we will get here to take this thing. Which object is suitable application? Okay. Yeah. Yes. Well, I'm saying. Right. Right. So the whole point was that you have to explore the different parameters that you are going to be looking in order to do it. Okay. Otherwise, you are going to be, if I tell you, do this, then I have okay. Questions, yes? How would you have this? While I enjoy a lunch, there's going to be working time. We need to plan how we make it. I will be around the lunch. After which I will where you will be able to show me your observations. I'm going to trust you. Write your observations. And say, this is what you have to say. This is what you have to say. Okay. Fair enough? Okay. With isometric and non-isometric. If you agree, isometric. Moment, yes?
The basic area of mechanics is completely explained.
Correct.
And we have some senses this is one of the I am so I so this motion aspect will be amplified that
You tell me. You tell me. Listen, I have something that I can tell you about. I can ask me to talk.
update
Beauty protocol. You know that this is a protocol. Good night. You know that protocol also is the different power elements. Which happens in longevity. How can I tell you that? What's okay? That's right. Based upon this, what is it telling you? You can have magic here. Okay? You can prove this to the skin. You can even have tattoo in the tube. What's the tattoo in the tube? You actually make a tattoo on the skin, which is going to remain there. You can get it back. So, your Adidas shoes, or your unbranded shoes, are coming from the same factory. Just because you're paid more for one doesn't make them the other. Right? Anything else, guys? Oh, right. B is the response by mechanics that mechanics innocent. Right, okay, we are then talking about totally different topic. Let's go there. How many of you have done things that I was looking at in some form or the other? One, well, two, three, we look. But we'll do some. When you have gate, what's okay? When you do gate analysis, what is the problem? How many bases of gate do you trust? How many nodes can I ask you? And come on, Dr. Google agenda. Right? Okay, but let's see how many gate bases do they identify? Huh? Typically, my understanding is that most people will say that that's four bases. Okay. And why are those four bases of gate relevant? Because one of the bad okay, is a significant. Concentric and eccentric is part of the gate. Talking about yeah, that. Others? Yes, yes. Except what does that mean? Double support and single support, right? Straight. And then you want natural person, right and left. So there are many factors of it, depending upon what the application. In my lab, it was gaining analysis of the purpose of market, which is largely to identify the and but using scores, the application of the increased computation. One of the factors that comes in gauge analysis would be one, which you cannot get about instead of such as an IMU or a video. See, one of the big changes that happened over the past years, because gauge analysis is involving a big lab with lots of cameras and it cost billions of dollars. Then, gauge analysis can be done with an Android smartphone. In fact, is a company came to India was making a software that there are a company one where you can take a smartphone and you record a person and you can some of that the cadence the swing guys and all of that. Then again, you can also take that same use. Another which is happening, I know here is for a person who has nothing, which is about in human sense. So you put the sensor inside the person and you can measure where the person touches the frequency. This is what we call gravity. What happens at the time is that typically the agnostic field go to what agnostic and agnostic. No? So you have, let's say my arm or muscle. If I'm doing this, my bicep is agnostic. Passing the and my tricep is agnostic. This is preventing. So I want to relax my tricep and activate my bicep. Same case for my leg. But I totally get activated of this. My hand doesn't move. At the same time, typically, we find that when people are exercising, cycling, walking and even the cycling in sports, they tend to activate, when they get achieve, they activate all the muscles simultaneously. And all the rest simultaneously. The repetition of that, consider cycling pump 0, 3, 6, right? So how do you define cycling? So what do you want to do? You want to have when this pedal is here, the other pedal is relaxed. So if with one foot I'm pushing down, the other foot does not push down. If you look at high-end sports bicycles, they have grips. Don't want to twist someone? No? Or don't you know? No, so that when I'm pushing down with one, with the other I'm pulling. So I'm not, with one I'm pulling, one I'm pushing down, with the other foot I'm pulling up. So my foot is coming up, right? So that improves the efficiency of my cycle. What happens is, when person is getting fatigued. When the person comes at this point, this foot should now relax. And this foot in the opposite direction should now start pushing in this direction. But if both the feet push, what am I going to do? Negative move. So, one of the things that with EMG fits is if the person is doing negative work. And here, the thing is, you don't need to really know how much the reporting generates. No, we're not going to multiply it for anything else. All we want to know is this muscle active? And is this muscle active? That's all I want to know. Which EMG, in most cases, will easily place. Will activate the lens. So I want to know is, let's say I have two muscles. One muscle active, relaxed. The other muscle is, it should get activated later. Okay. So when this is active, this is relaxed, and when this is relaxed, this is active. This is one aspect of sports medicine, which I do every while. Makes sense? Of course, there are other better ways people have said, how do you use energy? What are the other options? What the shoe says. With both the feet are pushing hard, and get a similar outcome. If it's without the EMG, however, in general, EMG would be another one is when people are standing. When standing, I have to have both my body muscles. Soleus and then here. My quadriceps and my hand. Both kind of be simultaneously. Because otherwise, while you were suffering, the activity should be very slight. Otherwise, I don't know what you see. Often people would say that it is easier to walk than to stand for a long. Now it happens. If on the other hand, if a person typically becomes weak up to the age, they fear never to fall. And so what do they do? They overactivate muscles where they the process. They start fatiguing very quickly. And they no, and their muscle become then at the joint. The activity becomes the force becomes. But the muscles are very active. So the force is weak, not because muscles are weak, but because muscles are coactive together, making the person fatigued, which is more of a psychological reason than a physical reason. The person was fearing, I'm going to fall. They activate themselves totally, not rigid. Process. The muscles are working hard against each other. And at that time, if you do not know what to do, you know, person, field therapist, and say, oh, we have to do this, bring you influence. Should I do tablets? The opposite. What's should I be told how to relax in a sense? Okay. So this is one thing which here this is another. So I to be more training. It's supposed to that's title. They're taught that when they're getting fatigued, emotional, they don't start trying to push it as much as they can. As soon as they start pushing as much as they can, then this starts overlapping. Higher and faster. So the difference between the hobby cyclists and the training cyclists in the trained cyclists would ensure that even when they are fatigued, they don't start pushing too hard. Make sense? So the gate person, how can you have this sense? You actually going to have one. Injury during one of the development stages. So what can happen? I think about, sorry, I buy it.
Any condition that they can stick with it.
Let me think about it. So, there are elements that I some things that I can find, I doubt. I do not have the feel. What else? Vibration is already have vibration. Vibration will have vibration something. But what is the limit for the still? Vibration. Vibration is when we need to in our body, muscle only can go. Muscle doesn't. On the other side, movements of muscle always working together. One doesn't move in the muscle, other side. So vibration is when these two pair, yes, I'm very well. Touching. Lunchtime, thank you, enjoy. And you know what the afternoon work is? You know what you have to do? I'll be here till 3. So if you do any work before that and have a question, I'll help you. Otherwise, so what I want you to remember is, I want you to be in with research students, not like undergraduate students. Experiment. After that, your observations. Remember, your opinion is not an observation. Opinion is opinion. Observation are facts. Okay? And have an opinion as well. You can say that this, based upon this observation, this is my opinion. Sure. But not mix a fact and an opinion. Fact is fact. Measure. Opinion is proportionally interesting. All right? Similarly,